Okay, another lesson on confidence intervals and their interpretation. So um, remember, we construct a confidence interval from a sample. We sample and we can construct a confidence interval. I'm only going to be talking about 95% confidence intervals for the proportion. From every sample, a 95% confidence interval can be constructed, and 95% of these samples will contain the true population of the proportion. 5% will not. Our sample either will or won't contain, our confidence interval either will or will not contain the true population proportion. Given the fact that most samples do contain the proportion, we think generally that our confidence interval is one of those. That's essentially how this works. So given the following information about a sample, n is equal to 100. Remember, n is sample size. So I've sampled 100 people, and it says p hat, that's the sample proportion, is 70%. I want to construct a 95% confidence interval for the proportion. I'm going to find my margin of error. On our course, we're going to take the margin of error to be about 1 over root n, which is 1 over root 100, 1 over 10. Given that this is in percentages, I'm just going to write that as a percent. So that's 10%, 1/10 or 10%. My confidence interval for the proportion. So my 95% confidence interval for the proportion is this. Well, it starts at 70% minus 10%, and it finishes at 70% plus 10%. So my 95% confidence interval for the proportion will be between 60% and 80%. Sometimes you'll see it written like this with interval notation, and sometimes you'll see it written as like this: 60%, 80%. So that's the same thing. These two things are saying the same thing. Notice the round brackets are saying exclusive. It doesn't really matter. I could put square brackets in there. It's not a huge big deal to say inclusive. I could use less than or equal here, or less than. It's not really a big deal. Construct a 95% confidence interval for the proportion. That's it done. Now, what does that mean? Well, you got to remember that 95% of these 95% confidence intervals for the proportion will contain p, 5% will not. So we've just done from one sample, but there's loads and loads of samples that we've taken, and from every single sample we could construct a difference confidence interval. And 95% of these will be containing p, 5% will not. So what are we saying? Well, one way to, I suppose, interpret this, although there is debate, I think, around this, is that I could say I am 95% confident that the proportion lies between my lower limit of 60% and my upper limit of 80%. Of course, p either does or it doesn't. So it either does lie between 60% or doesn't lie between 80%. In order to find out exactly where it lies, I would have to look at the whole population. However, we generally don't, because of time and money we sample. And we know that 95% of all of these 95% confidence intervals for the proportion will contain the proportion, the true population proportion. 5% will not. So it is possible that our confidence interval here will not contain the proportion. There's a 1 in 20 chance that it will not contain the proportion. There's a 19 in 20 chance that it will contain the proportion. I want to have a look at margin of error. Remember, we said we defined margin of error from our course. It's an approximation, of course, to be about 1 over root n. Okay. That's a little triangle relationship, a bit like our old DST relationship, where you would have seen it like this, where we've got E, 1 and root n. So I can, given the margin of error, I can find the sample size. Remember, root n is going to be 1 over E. So root n is going to be 1 divided by 2.5%, which is 40. That'll be done in your calculator. If root n is 40, well, then is equal to 40 squared, which is 1600. So I can work out the sample size given the margin of error. Okay, really useful to kind of remember the margin of error in this kind of way. We can make E the subject of the formula or root n the subject of the formula. Once we find root n, we just square that to find out. Okay, let me look at one more example of constructing a confidence interval. A sample of 900 people were asked if they believe in the existence of alien life. 600 said they did. I want to construct a 95% confidence interval for the proportion. Okay, so I want to construct a 95% confidence interval for the proportion. My 95% confidence interval for the proportion well, it's always p hat minus E up to p hat plus E, where E is the margin of error. In this case, p hat is 600 out of 900. Which reduces to 2/3, which is approximately equal to 66.7%. Let me write that as a percentage. So 66.7%, subtract the margin of error. The margin of error, what's the margin of error? Well, it's equal to 1 over root 900, which is 1 over 30, or 0.033, which is about 3.3%. So my confidence interval goes from 66.7 minus 3.3 up to 66.7% plus 3.3%. So my confidence interval is going to be this. That'll go from a low of 63.4% up to a high of 70%. Okay, and I can write it like that. I could also write it as an inequality. I could also write my confidence interval for the proportion like this. P lies between 63.4% and 70%. I could write it like that. That's also a way of writing the same thing. This is using interval notation. So our confidence interval suggests that the true population proportion lies somewhere between 63.4% and 70%. Remember, 95% of 95% confidence intervals for the proportion will contain the true population proportion. 5% will not. There's lots of people in the world. We took a sample of 900. And we've made some deduction, something called an inference about the population based on our sample. So we've made an inference about the population based on our sample. But there's loads, there's an extraordinary number of samples of size 900 you could take of from the population of the world. And from every single sample, you could construct a 95% confidence interval for the proportion. And 95% of these intervals will contain the proportion, 5% will not. Which do we think ours is? Well, if I had to guess, 19 out of every 20 do contain P, so we'd guess that ours is one of the 19 out of 20 that do contain P. Okay, that's essentially what we're saying. And a way to state this, I suppose, is that we're 95% certain that our confidence interval does contain P. I am 95% certain that the true proportion of people who believe in the existence of alien life lies between 63.4%. 63.4. Something happening to my board here. Let's hope I can do this. 63.4% and 70%. That's what we think based on our sample. I'm 95% certain that the true proportion of people who believe in the existence of alien life, remember that's what we were asking about, who believes in alien life, do you or don't you? 600 said they do. That 95%, we're 95% certain that the true proportion of people who believe in the existence of alien life lies somewhere between those two numbers. Okay? Why are we 95% certain? Because we know that 95% of all the confidence intervals for P that can be constructed will contain P. 5% will not. So there's a 1 in 20 chance that ours does not. There's a 19 in 20 chance that our confidence interval does contain the true proportion of people who believe in the existence of alien life. So 63.4 up to 70%. Let me just think about one last thing. Suppose I have a friend that claims that 75% of people believe in the existence of alien life. We all have friends who quote these crazy statistics every now and then. And so I go and take my sample. 900 people, 600 said they did believe in alien life. And I come up with my 95% confidence interval for the proportion. And I say, well, I think the proportion lies between 63.4% and 70%. What do I tell my friend? Well, ultimately what I tell him is I think he's wrong. And the fancy way we have of saying this is that I reject my friend's hypothesis. So I'm going to reject his hypothesis. This is a hypothesis. It's some claim he's making about the population, and I'm rejecting it. I'm saying I reject that. Why am I rejecting it? Well, because it doesn't lie within the boundaries of my confidence interval. I'm 95% certain that, the true population proportion is somewhere between 63.4% and 70%. I could be wrong, but based on my research, I'm going to disagree with him and I'm going to reject his hypothesis. Okay? Keep remembering that 95% of all 95% confidence intervals proportion will contain the proportion, the true population proportion. 5% won't. Okay? Keep remembering that. Okay? And remember how to interpret that. I'm 95% certain that the true population proportion of people who believe in the existence of alien life lies between 63.4% and 70%. So I am going to reject my friend's hypothesis where he claims that 75% of people believe in the existence of alien life. Okay, this is something called hypothesis testing, which we'll be looking at in our next video. So get used to that stuff. Make sure you understand how to find the margin of error. Remember, a 95% confidence interval for the proportion is always calculated as follows. P hat minus E is my lower limit, P hat plus the margin of error is my upper limit. That's our confidence interval. You got to learn that by heart and be able to find the proportion, the sample proportion, find the margin of error. Then it's just interpretation. Okay? Keep practicing.